Alright, let's try 7e. So now we know how to use all the radians and unit circles and know how the sine cos 10 equations work. We can now solve some problems, and obviously we're going to start easy, but then we're going to get into some problem solving questions as well. Okay, so let's begin with this. You can give this a read if you want, and there's nothing really to write down. We should be able to use graphs. We should also be able to use technology. We should also be able to use algebra to find answers to trigonometric equations. So that's what we're going to try. First of all, we're going to try graphical solutions. Graphical solutions are the easiest ones, obviously, because all you have to do is know how to read and draw graphs. So for the example 9, solve cos x equals 0.4 for 0 to 10 and using the graph of y equals cos x. So what this means is we want to find when cos x is 0.4. So have a think about it. Are we trying to find x or are we trying to find y? Kind of gives it away, right? Because it says cos x is 0.4. So we're trying to find x. Okay, we know y, right? Because our equation y is y equals cos x. So technically, whenever we have cos x and you have an equal sign and an answer to it, the answer is the equivalent of a y. So even though it looks a little bit foreign, that's what we need to know. So y is 0.4. We know that just by looking at that equation. That's what it basically tells us. So what that means is, how do we use this graph? Well, we've got a graph of y equals cos x. We want to basically know every x values that it gives our y value of 0.4. That shouldn't be hard. So all I need to do is locate where my y is 0.4. Okay, be careful, my y. Okay, let's have a look. This is a scale of 1. Obviously halfway would be 0.5. So let me have a look at the scale. So 0 is over here. I'm going to assume it goes up by 0.1. So is this going to, is it? Let's double check. 0.1, 0.2, 0.3, 0.4, 0.5. Don't always just assume. You just got to actually kind of try and let it out. So now using a line, I'm going to kind of draw a line that's at 0.4. Wow, I don't know where that started. Don't like that. Can I delete it? Can I delete it? Is that deletable? I actually don't know. Hold on a second. Alright, let me try that again. So at 0.5, it starts at a random thing. So I'm just going to maybe extend it and then I'm going to move it, hopefully. Is it going to move? No. Okay, well that's annoying. I'll just draw it by hand then. So this is the line of 0.4. It's a little bit dodgy because I'm drawing it by hand. If you obviously have a ruler, you would use a ruler. You're going to do your best to read these answers. Okay, cool. So where are my x's intercepting that pink line? Well, for it cos x to be 0.4, it will have this value. Let me dot it down maybe in a different color. It'll be at this intersection here, so we should be able to read that point somehow. And then at this intersection, so we've got to read that point. And another one over here. So all I have to do is read those. So x is approximately, the reason I write approximately is probably because I won't be able to exactly know the answer. How is this sorted out? Is it 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Yep, so each box is 0.1 in the scale as well. So approximately 1.2 for the first one, 5.1 for the second one, and the third one, 1, 2, 3, 4, 1, 2, 3, 5, I think, 7.5. So these are my approximates, and that's it. Alright, we obviously can't do exact values, it'll just be approximate. So if I try inverse cos on the calculator and see what we get of 0.4, make sure it's in. So I get about 1.15, which is approximately 1.2. So it's not exact, but it'll do. Alright, so that's that one. So you should now be able to use graphs and do some E.1, question 1 to 4. And then once you do that, come back to it, or you can listen to this one first if you would like to. I'm going to, because I can't really show you exactly how to do it on the calculator online. I can show you in class as well, but I'll just explain to you how it works. So with these two, you've got an equal sign, you've got an equation 1 on the left-hand side, and then an equation 2. As you can see, this is going to be like a linear. Oh, and this is going to be like some sort of wave graph, hopefully. We'll see. But anyway, what you need to do is just graph both of them in the graphing section, and then find intersections. And that's really it. Now, it is important that we set the range domain right, so we'll go through that in class, and I'll show you, hopefully, in class. So we'll skip this one for now, but hopefully, after I show you, and after we write some notes, we can come back and do 70.2 1 to 4. Using graph is probably the easiest option. But now we have to use algebra, okay? So this is the hard part. But we've already kind of done the hard part already when we did the multiples, okay? So when we looked at kind of 5e and looked at all of these and looked at different answers and solutions and drew our unit circles to figure it out, you've basically done the hard work. So let's see if we can keep going with these. Just a bit of a reminder of which angles, what are the angles. So let's do this one. Solve for x on the domain 0 to 2 pi. Okay, cool. Cos x equals minus square root 3 over 2. So first of all, I need to find whereabouts my cos x is minus square root 3 over 2. Well, let me draw a unit circle and have a little think about it first. All silly turtles crawl. So where is my cos x going to be having a negative answer? Well, in my all silly turtles crawl, it should be pretty easy for me to see that cos is positive in the first and fourth quadrant. So my cos is going to be negative over here, these two quadrants. Okay. So when I find the answer using either the calculator or the unit circle, I should be able to apply it. I'm going to be obviously finding this angle first. So I'm going to change my calculator settings, change it to radians. Let's see what happens. Depending on if you have a new calculator or not, it'll give you the answer straight away. So I've done x equals, in order to find my x value, if I just write it over here, x equals inverse cos of minus square root 3 over 2, I got the answer of 5 pi over 6. Now I should be able to see this on the unit circle as well. So if I go over here, I see my cos values, my x values. So over here, I've got my cos value of that one, and then that one is my cos value. I should be able to, hopefully if you have the correct version of the unit circle, it should say 5 pi over 6 on that angle here. But obviously for some reason, they didn't write it down. I might go copy and paste it from another section so we have it right in front of us. So bear with me. You should already have a copy of it in your books because I printed some out for you. So maybe I might just, I was going to screenshot this, but it's got some stuff on it. Hold on. Alright, so I'm going to screenshot this unit circle just so we can work around with it. Here we go. Didn't want to work. Okay, didn't want to work. We'll just have to go back and forth with it then. But as you can see, 5 pi over 6 is definitely what we had. I'm going to try one more time. 5 pi over 6. And then you should be able to also read this answer off as well. So 7 pi over 6, but I'll show you how to do it algebraically as well, just in case you don't have that on you. Oh, there we go. That's a bit better. Alright, so we got 5 pi over 6. So that angle is 5 pi over 6. So how are you going to find that angle? Okay, so 5 pi over 6, and then what I would do is, can you see how that the red angle and that angle is the same? So I would do 2 pi, take 5 pi over 6 to see what I get. So I get 7 pi over 6, and that's my answer. So therefore my x is 5 pi over 6, and 7 pi over 6 is my final answer. Alright, let's do B. Alright, so for B, I've got 2 sine x take 1 equals 0. Now, I can't use it straight away. I need to manipulate my data and go 2 sine x equals 1. So I've removed the 1. And then I'm going to remove the 2 by just dividing it. So therefore, my sine x becomes a half. So let me draw a unit circle to see where about that would satisfy my answer. All silly turtles. Cool. Where's my sine x going to be a positive number? Over here, as well as over here. So when I find my first angle, whatever I do, I inverse sine. So if I go inverse sine of a half, that should give me my first. It always gives you the first answer. So that's pi over 6. So that means if I want to find that angle, okay, I just need to go pi take that angle. So my second answer is pi take pi over 6. Hopefully you are following. If not, please come and ask in class because it's really, really important that you understand what I'm doing and how I'm doing this. So let's double check that my answer is correct for this one. So x is pi over 6 and 5 pi over 6. Okay, so my answer was a half. So my y coordinate was a half is what I'm looking for. 5 pi over 6, which is the first answer, and then over here, pi over 6. So those are the correct answers, and I can see that straight away. Alright, I'm going to try C quickly, running out of a bit of time. I've got 10x plus square root 3 equals 0. I can't use this straight away. Again, I'm going to manipulate data, move the square root 3 on the other side by taking it, and then I have to figure out what to do with this. So where about is my tan theta going to be negative? Well, my tan theta is going to be negative over here and over here. So if I find that first answer by doing inverse tan, I should get my first answer. Which is negative pi over 3. Okay, so this one actually gave me that answer. So that's the pi over 3 degree. So that angle and that angle is the same. So if I want to figure out my second answer, it's going to be pi take pi over 3. Alright, so my first answer is 2 pi over 3. So that's going to be, if that's going to be that angle, that first angle. So technically I should be able to write my answer as, x equals negative pi over 3 and 2 pi over 3. But unfortunately this is not 100% correct because we actually need to write our range is 0 to 2 pi. Unfortunately this one does not is not in that range. So what I need to do, instead of writing that minus pi over 3, I'm going to manipulate the data and go 2 pi. So from 2 pi, I'm going to do take pi over 3 and figure out this angle. Okay, so does that make sense? Hopefully it does. Chuck it in your calculator or do it manually as well. You should be able to do that. I get 5 pi over 3. So instead of writing that option, you actually write the next option. Alright, so let's just double check on my 5 pi over 3. So it would have been that one. And what's my other option? 2 pi over 3. So if I use the sine and cos coordinates and then divide it, I should get minus square root 3, and I can see that from looking at it both. If you don't understand how, just put in your calculator sine theta divided by cos theta. So that would be, so for this one it'll be negative 3 over 2 divided by half. That should give you negative square root 3. This one, 3 over 2 divided by negative half, that should give you negative square root 3, so that if you want to double check. But otherwise, you should be able to do example 1. I'm going to pause the video and make more for 12 because I'm running out a bit of time. So write all that down.